last session, we have discussed about the production of phenol by cumin peroxidation process, toluene two-stage oxidation process, and the rashing process. In this session, we are going to discuss about the phenol production by remaining three processes like phenol from chlorobenzene route, phenol from benzene sulfonate process, and direct oxidation of benzene to phenol. Just we recall what you have studied in the last session. In the last session, we have discussed about the chemical reactions that are taking place in the production of phenol from cumin peroxidation process. For peroxidation, aqueous emulsion is prepared using emulsification agents. The operating conditions in the reactor is normal temperature and pressure, and the emulsification agent is alkali like sodium hydroxide. During the hydrolysis process, 10 to 25% sulfuric acid is used. The operating condition in the hydrolyzer is a temperature of 55 to 65 degrees Celsius and atmospheric pressure. The process that is taking place in the cumin peroxidation process, here cumin, that is isopropyl benzene, is made by alkylation of benzene with propylene, is mixed with recycled benzene and sent to hydrogenator. Unsaturates and alpha methyl styrene are converted into saturated material to avoid the undesirable decomposition of peroxide during the oxidation step. Hydrogen over nickel catalyst at 100 degrees Celsius in the batch reactor is usual process for purification. Oxidation is carried out in the presence of air in an aqueous emulsion stabilized by an alkali such as sodium carbonate, sodium hydroxide in the pH of 8.5 to 10.5 range. Vent gases are passed through the condenser for the recovery of hydrocarbons. The cumin peroxide thus formed is cleaved in an acidifier containing 10 to 25% sulfuric acid, which is then agitated in a vessel at a temperature of 55 to 65 degrees Celsius. The reaction products are separated into an acid layer for recycle to the cleavage vessel, and an oily layer containing 75% by weight of cumin, 14% phenol, and about 8% acetone, and 1 to 2% alpha methyl styrene and acetophenol. The mixture is separated in series of 4 distillation columns, the last 3 of which are operating under vacuum. Phenol in the overhead of the last column fractionator is purified by crystallization. This is the cumin peroxidation process. In the toluene oxidation process, toluene is oxidized in the 2 steps. That is, one is oxidation of benzene to benzoic acid in presence of cobalt naphthenate catalyst at a temperature of 150 degrees centigrade, and this benzoic acid is further oxidized to phenol in presence of cupric benzoate catalyst at a temperature of 220 degrees Celsius. The process, the Two-stage oxidation process is used. Fresh plus recycled toluene are mixed with a small quantity of cobalt naphthenate catalyst is charged to the reactor, which is liquid-filled tower through which air is passed. Cooling tubes are actually cooling tubes are provided to remove the exothermic heat of reaction. The reactor is operated at a temperature of 150 degrees Celsius and 3 atmosphere pressure. Excess air is used here, but the toluene conversion is limited to 40% to avoid the other side reactions. After the reaction completes, the impurities such as benzaldehyde, benzyl alcohol, benzyl benzoate, carbon monoxide, carbon dioxide, and the conversion of toluene is about 40% to yield benzoic acid of about 90%. The reactor is then facilitated with vent after cooling and partial condensation. The mixed hydrocarbon vapor stream. Liquid product from the reactor enters to the distillation column to separate the toluene and other organics. All other impurities do not dissolve in water and leaves the wash unit for recovery of heavy ends. Benzoic acid is then crystallized, and these crystals are washed with water and then melted and fed to the second stage oxidation reactor, where oxidation is carried out in presence of cupric benzoate catalyst. After cooling, the phenol is actually formed. The reactor conditions are 220 degrees Celsius and a temperature of 1.3 to 1.7 atmosphere. The vapor enters to the fractionating column where it separates the benzoic acid and other compounds. The top product is actually the phenol water stream, which is separated by fractionation and withdrawn as a product. The bottom product is the from the second stage oxidation reactor consists of organic compounds and is sent to water wash. This water phenol mixture is mixed with the water and fractionated to separate benzoic acid. Crude phenol is fed to the fractionator to obtain the purified phenol product as the bottom product and phenol water mixture as the top product. The top product here is an azeotrope which is then separated and the product is taken. Phenol from benzene. Here phenol can be manufactured from benzene using several ways. Benzene hydrochlorination from benzyl chloride followed by hydrolysis of benzyl chloride to form phenol. Benzene chlorination to form benzyl chloride in which is transformed to sodium benzoate, and phenol is formed by using sodium hydroxide and HCl. Benzene sulfonate process. In phenol is also manufactured by rashing process in which hydrochlorination of benzene is carried out in presence of HCl and then oxidized at a temperature of 240 degrees Celsius in presence of ferric chloride and cuprous chloride catalyst to monochlorobenzene. This monochlorobenzene is then hydrolyzed in presence of water at a temperature of 350 degrees Celsius and in presence of silica as catalyst, which gives phenol and hydrogen chloride for recycle. In today's session, we are going to discuss about the phenol from chlorobenzene route, phenol from benzene sulfonate process, and phenol from, that is, benzene direct oxidation. Let us see this, how phenol is manufactured. Phenol from chlorobenzene route. There are three reactions to convert benzene to phenol using chlorination. These are the reactions: chlorination, castilization, and hydrolysis. In the chlorination, benzene is chlorinated at a temperature of 85 degrees Celsius in presence of iron or ferric chloride catalyst to monochlorobenzene. This monochlorobenzene is then reacted with sodium hydroxide in castilization step to sodium benzoate. This sodium benzoate is then hydrolyzed in presence of HCl to phenol and sodium chloride. This is the flow diagram for the production of phenol from chlorobenzene route. Here, dry benzene and catalyst of iron turnings or anhydrous ferric chloride are charged continuously into a chlorinator. The partially chlorinated mixture boils up into a fractionating column. Benzene is fractionated from the top of the column and returns as a recycle, while monochlorobenzene is withdrawn near the bottom of the column. Near the bottom of the column, right? Chlorobenzene and dilute caustic soda, about 10%, are mixed in a pump in a mole ratio of 1 is to 1.25. Diphenyl oxide, about 10% by weight, is added to repress the formation of more diphenyl oxide, and the mixture is pumped through a preheater. This is the preheater, and then to a multiple effect, multi-tube reactor where castilization occurs, and here castilization occurs at a temperature of 425 degrees centigrade and 330 atmosphere pressure. Heat is removed from the reactor reflex by change in feed preheater. The cooled hydrolyte is acidified in a neutralizer which liberates phenol and sodium chloride. The sodium chloride salt is recycled to an electrolysis unit to produce required caustic soda after electrolysis. The phenol is stripped of diphenyl oxide and other minor impurities by a vacuum distillation column. A portion of diphenyl oxide is recycled and remainder is redistilled under vacuum for commercial production. This is the process which is taking place in the manufacture of phenol by chlorobenzene route. The next method of production is benzene sulfonate process for phenol production. Here the chemical reactions are here reaction takes place in four steps: sulfonation, neutralization, fusion and acidification. In the sulfonation process, benzene is sulfonated in presence of 98% sulfuric acid. So, to benzene sulfonate, this benzene sulfonate is neutralized in presence of sodium carbonate to sodium benzene sulfonate, and it produces sulfur dioxide and sodium sulfate. This sodium benzene sulfonate is then fused in presence of sodium hydroxide at a temperature of 300 degrees centigrade, which gives sodium benzoate. This sodium benzoate is then acidified with sulfuric acid and excess sulfur dioxide to phenol, sodium sulfide, and sodium sulfate. This sodium sulfide and sulfate are separated from phenol by distillation. This is the flow diagram. Here, benzene vapors are made to react with liquid sulfuric acid in countercurrent reactor. Here, to form benzene sulfonic acid. Excess benzene carries off the water formed in the reaction to avoid diluting the acid and slow downing the sulfonation. The sulfonator is designed so that only few percent of free sulfuric acid remains before liquid is discharged to the neutralizer. The neutralization accomplishes by rapid adding the reactor liquor to a solution of sodium sulfite in this neutralizer. Here, sulfur dioxide is released and pot residue contains sodium benzene sulfonate in solution and precipitated sodium sulfate. This mixture is filtered in a pressure filter. That is the second step. Next step, pressure filter here, and then it is moved to batch fusion. A cast iron a fusion pot containing molten castic is kept at 300 degrees centigrade, and it is direct oil or gas fired to heat the content to a required temperature of 300 degrees centigrade. The sulfonate is slowly added at the bottom of the pot, and reaction is allowed to continue for 5 to 6 hours. The melt is then diluted with water, acidified with sulfur dioxide to form the neutralizer, and the final pH is adjusted with dilute sulfuric acid. The released crude phenol floats on an aqueous solution containing sodium sulfate, sodium sulfide, and a small percentage of phenol. The crude phenol is then refined in vacuum distillation columns. The aqueous layer is steam distilled to recover more phenol. The part of the sludge is in the used in the neutralizer step. The balance is sent to paper mill or crystallized and dried to yield anhydrous sodium sulfite. That is the phenol production by benzyl sulfonate route. Next method of phenol production is direct oxidation of benzene. Phenol production by direct oxidation of benzene. The reactions involved are chemical reactions. Here, benzene is hydrogenated to cyclobenzene. The cyclobenzene is oxidized to cyclohexanol and cyclohexanol, and this is then produces phenol and hydrogen. Applications of phenol. Phenol is used in the production of phenol formaldehyde for thermosetting resin, in herbicides, in insecticides, in the production of pharmaceuticals and dyestuffs. In the petroleum refining, it is used as a solvent. Right? These are the applications of phenol. Right? Next, we'll see some of the MCQs. Question number 1. The reaction involved in production of phenol by chlorobenzene route in series are chlorination, castization, hydrolysis, castization, chlorination, hydrolysis. Option 3, chlorination, hydrolysis, castization. And option D, hydrolysis, chlorination, and castization. The right answer is A, that is chlorination, castization, and hydrolysis. Next, question number 2. Dash is added to suppress the formation of more diphenyl oxide. Options are monophenyl oxide, B, diphenyl oxide, C, triphenyl oxide, and D, none of these. The correct option is option B, diphenyl oxide. Question number 3. Fusion of benzyl sulfonate is done in dash pots. Options are A, mild steel, option B, stainless steel, option C, cast iron, option D, A and B. The right answer is answer C, that is cast iron. Fourth question. The oxygenated fraction of benzene is dehydrogenated to phenol in presence of dash catalyst. Options are nickel, option B, silver, option C, copper, and option D, iron. Right answer is option A, that is nickel catalyst. Question number 5. In the production in petroleum refinery, phenol is used as dash. Options are A, dehydrating agent, B, solvent, C, dehydrogenating agent, and D, none of these. Right option is option B, that is solvent. Right. Thank you.